Hey, welcome back. Let's take a look at the two types of bonds that are going to exist, and that is ionic and covalent. And these have to do with the difference in the electronegativity of the two compounds. Ionic compounds, on one hand, have a very large difference in their electronegativity. Therefore, one of the electrons or more is actually going to be taken from the other element, causing a definite positive and negative charge to happen. And this positive and negative will cause the two to be attracted to one another. The positive will be the metal, and the minus will be the nonmetal. Now, you could look up a chart that has several different numbers and values for all the electronegativities and do math and have a bunch of scales, etc. Or you could just kind of look right here at this line and say that this line represents a boundary. Everything to the right over here is going to be a nonmetal, and everything to the left is going to be a metal. So anytime I have an element from the left-hand side with an element from the right-hand side, I have an ionic compound. One thing that you must remember to do is, you see how hydrogen is not attached? It needs to be over on this side. So pretend like hydrogen is somewhere over here when you're doing this. Now, covalent bonds, on the other hand, there's not a great big difference in their electronegativity. And so there's not one element that's really powerful enough to pull an electron from another. So when they bond, they actually are going to share their electrons. So there won't be any formal charge with covalent bonds. And they will both be from the right side of the table. Now, electronegativity can play a part in something called polar, or the polarity of a bond. Is the bond polar? Okay. Now, this occurs whenever there is a stronger electronegativity. So if we look at the chart, we know that fluorine is the strongest. We see oxygen here, hydrogen somewhere over here. So we know that oxygen is much stronger. So it's going to draw electrons towards it. And as it draws electrons towards it, we can imagine that there will be a pole here and a pole here, creating what we call a dipole moment. And because of the dipole moment, because there's a positive and a negative, we would say that H2O is a polar molecule. Now, if there is the same difference, but there is some kind of symmetry, then there won't be a great pull because it will equal it out. So anytime an element is surrounded by the same thing, like let's take a look at CO2, we see that carbon will be surrounded by oxygen. So there is a pull, but the pull is equal, right? And so because the pull is equal, there will be no clear winner. So this is non-polar. So that's basically how we can break down further the covalent bond. Is a covalent bond can either be polar or non-polar based upon its symmetry and based upon its electronegativity. Okay, so that's the main two types of bonds and the different ways we can look at them. See you next time. Bye-bye.